Year 2024, month of October. This is a special video. It's not part of any series on the channel, but it is about the theme of this channel, which is the intersection of computer programming and energy consumption. It is currently the year 2024. We're heading into 2025. Since the year 1800, just 225 years ago, historically yesterday, or maybe last week, the global consumption of energy, and that's everything in every form, electrical, gas, oil, coal, combustion engines, whatever, all together, has gone up and up and up as the years have gone on. And world civilization is a device which has a ever increasing power rating. And this is now our infrastructure, and we can't run our civilization and feed 8 billion people without it. Can we keep this up? That is something I hope technologically we can do, but one of the big things on this channel is that we need to be prepared to possibly plateau or possibly be prepared for the reduction of that power capacity. First off, know which big wide area grid you are on. The wide area grids are these large electromagnetic machines that span over continents, and you live inside one of them. Here on this map, the big orange, that's the old Soviet grid. This dark green one is the continental European grid. China's main grid is this purple one, and it is currently the highest power capacity, and Europe's is the second highest. And this main North American, northeastern one, that is the United States and Canada share, is the third highest capacity. Quebec has an independent grid. This is the western United States and Canada. We see parts of Alaska have a small independent grid. I'm currently here in Texas, which has a small independent grid. Our friends in Mexico have a unified single national grid. Small island nations are kind of patchy with what their power grids are going to be. Some are well developed, like the UK, Ireland, South Korea. Japan has 3 major grids. Australia, like the United States, has a western and an eastern grid. New Zealand has one for North and South Island. This part of continental Africa is a little patchy, although the South African grid is actually, it's there. Saudi Arabia has a small independent national grid, so Mecca is powered by that. India, highest population in the world, and they have a unified grid. All right. So, all of our computer programs that are going to be running on some server somewhere are making those server farms devices that consume power off one of these grids. I think it's important for you to know which grid your stuff is running on. You are an accessory to one of these grids. In the last couple of years, everything on the internet is getting now filtered through AI. AI has greatly multiplied the electrical consumption of the whole internet. Uh, Here's an article from Wired. Stress on local power grids and any industrial process uses water. And so we are consuming water. We're consuming electricity, a lot of that from coal and natural gas, those are not renewable. Wind and solar and nuclear are great, but they are very complicated and they still require oil and natural gas for their backups and their transportation of all the equipment. So as the oil and natural gas is either depleted or just is not liberally allowed by some energy policies, you're going to have some problems. If you are just developing at home, something you can do to get a feel for this is to get one of these outlets. This is a special outlet that actually you can plug your computer into, your development machine, or like maybe a Linux home server that you run your programs on. And it can actually tell you exactly how much electricity your server is using. And you'll be able to see by how you change the code or change the way your website works whether or not the whole thing's becoming more energy efficient. This is something that is gonna matter, possibly in the future. We cannot just assume that there's just going to be more and more energy. We need to start trimming down and making our programs energetically lean. We need to put the science back in computer science, learn some basic electricity. As I've mentioned before, in the energy efficiency of programming languages video, the lower level systems level languages might be harder to use, but they use way less energy. Ada is very safe, kind of mid-range, but it's using more energy than C and C++. Rust gets pretty down low, close to C and C++, and that's one with modern features. And of course, the interpreted languages are very high, and the hybrid languages that run on virtual machines are pretty high, like Swift. And there's more than one way to measure the energy efficiency of a programming language, but gives you an idea. It is good to know C and C++ and Rust going forward, because your programs are going to consume less energy and they're going to save your grid because you measured them. All right. So when I speak of language transitions, I think we also need to be thinking about the paradigm transitions, because OO we can show, especially for the hybrid languages like Java and C#, it's an expensive paradigm energetically. But Rust is not, and Rust uses trait-based polymorphism instead of object-oriented polymorphism. So knowing how to go from one paradigm to another, really regardless of the language, is a very important skill. You might have just learned OO in formal education, but we're just going to have to learn the other paradigm. I think a study needs to be made about what is the energy efficiency of COBOL. Our basic banking transactions are a large part of what computers have historically been for, what they're still for. And COBOL, for all we know, might really be this giant invisible energy hog. And so it's causing even more problems than simply the problem of not having the amount of developers we need for it. So, I hope in this video you learned something new and you begin to really measure your programs because they are consuming something finite. Power is not magical, it's got to come from somewhere. And we can't always depend on ever increasing, cheap, abundant power. Thank you.